So why should we change the file format? Well, one of the reasons is that in the last 20 years I got at least 1 million requests. How can I change the channel? How can I reverse the polarity? And how can I switch the channel, etc., etc. And the second reason is that if you do want to do some mathematics on the channel, you always have the problem to rewrite the binary data into the Metronics format using the LSB value and converting the doubles into integers. So that is a huge problem, and to overcome this problem we can change the format. And the name is atss for the stream format, and which consists of a pair of files, which is just the atss file, which is just strict binaries of double, and that means you can open it with NumPy or with Julia and with C and Fortran easily. And also quite important is that the ADU will scale the files to millivolts per kilometers, so that you later can concatenate these files easily together. Or when you use a simple plot program, the electric field is always normalized to millivolts by kilometers, and the magnetic field is written as millivolts. The thing is that the file name itself is part of the header. That means the information about the serial number of the system and the channel number and the channel type and the sample rate is encoded in the file name itself, and it is not repeated inside the JSON file. So the corresponding JSON file has the same name but a different ending, and there is no repeat of any of these values. So simply spoken, if you change the serial number of the system, the channel type or the sampling rate, it is changed. You change the file name for both and you got a new sample rate or so whatever. Whether this makes sense or not is not the question. The thing is to understand that the file name separated by underscores is part of the header itself. Not encoded in the file name is the run, and above the run will be the station name. So that means you can easily move runs and stations and rename the run or reorder the runs regardless of the data which is inside. So also this simplifies the administration of the data very much. The entries is a dozen entries which are needed. That's the date, time, latitude, longitude, all using ISO formats, and elevation in meters, resistance, either the contact resistance of the electrodes or the sensor, units, either millivolts per kilometer or millivolts, and so on. So that is very easy, and I'll show you that now. The other thing which I show later is where's the stop date. We don't need the stop date anymore. And especially when we concatenate the files, this is hindering because you have to re-edit the header. But the system, when it's used on a remote island for permanent recording, can chop the binary data streams every 1 hour, and you can simply concatenate them. And then you do not need to re-edit the header. So that means you concatenate them together, and the software automatically can determine the end of the stream. So this here is the header for an electric field, and as you can see, it contains very simple data. That's the date time in ISO format, resistance, units, filter. It's mentioned which board is used and which board filter has been set. This is maybe necessary for precise calibration. However, the systems of Metronics will always use the same filter settings for all channels, except you destroy this manually. And a big step ahead is for the magnetic field that the system will always write the correct calibration function of the sensor into the JSON format. And that means you do not need to look for the calibration. Where is it? You do not need to find out what was the chopper setting, which is for sure mentioned here. But if you take this, then you have the corresponding calibration data inside the JSON file. So this makes life extremely easy. If you use the Metronics software later, which is about to finish this year, you will see that we have survey and we have a station with some metadata, and we have here the real data, station name, and then the runs. And this is almost exactly like the USGS survey wants to have it. Yeah, that is here the progress of the MTH5 format, and the Metronics format is a simple copy. So it's simply like an unpacked MTH5 file so that you can use your binary operation quite easily. And you later can pack and go it back into MTH5. That is the deeper meaning. The community is very slow. Presently, we have some geophysicists which are working on the file format. That's quite slow. On the other hand, under the project name MT Hotel, I invite people to participate. So all what I'm writing is open source and it's available on GitHub repositories. So shifting, moving, using Python, C++ is now quite easy. I've made a small Python notebook, and for sure I have explained the header, but it is a simple JSON file, so that is not of importance. What you can see here is when I open the file, I just provide the file name without extension, and later I will look for the binary data and for the explanation of this binary data. And since this is a JSON file, I obtain a so-called Python dictionary when I open the file, and then when I open the file name with the extension atss, I get a NumPy array which is very, very easy to read, and you can force 64-bit because these are doubles, and then you can force the amount of bytes you want to read. So here we read 1024, so extremely easy. So as you can see, with a simple plot, we plot the first 1024 data points with a few lines of Python code. So that is very, very easy. The other thing is that most of my students always want to do some mathematics, let's say d-spike or d-trend, or do something in the time series, in the time domain, which is unfortunately underestimated in data processing to do something. And the biggest problem in time domain processing is rewriting the data into the format of the manufacturer. So that would be the old ATS format. And this exactly is not necessary anymore. So here we see smoothing, and that's the red line. And for sure, the data, the time series is shorter. But when I do this for all 5 channels, the data will be still consistent. And you do not need to rewrite the header. You just run your processing on the time series. Whatever you do, if you do it for all channels consistently, you can just save the data and reinitiate your MT processing or whatever it was. And that is the super strength of this data format. Right? Later, when you find an algorithm in order to enhance the time series, you can later take care about the lag at the beginning, and the lag at the end you don't need to take care because the ending is not visible. Calibration is easy. You take the data from the JSON file, you grab the frequency, amplitude, and phase. So here I show the amplitude, and you simply plot the data. If you want it old style, for sure, then we have a small loop and divide by 1000 and divide by the frequency, normalize the frequency, but that is old-fashioned style. Yeah, FFT is also, at least with Python and with some other languages, easygoing. You just make your mind up about the normalization of the window and the calibration of the window, but that is quite easy. And also here, with a few lines, you make a spectra, you calibrate the spectral window, and you simply plot the raw amplitude. Now, when we look at the calibration, we can see that if we divide by this function, we get a huge amplification of the lower frequency part, if you like so. So we take the values from the FFT and we simply apply the transfer function. Here I use in this case the theoretical function now, which is fine. And then we see suddenly the field in nanotesla, which is never the same like the flux gate data, but if you use smaller parts, you should see the real nanotesla without offset. The offset cannot be measured by the coil for sure. So with a few lines, you are done, and that is one of the strengths. And the other one I can show you on the console. I have prepared the command. If you have time series, this is the second and this is the first one, the idea is that with a simple cut command, you can concatenate the binary data. If you have a permanent remote station and transmit by mobile phone, you can chop it into smaller segments and therefore have an efficient transfer all over the day. So if I press enter and look at the data, then you can see that was one file, and this file has now the double size. Also when the recording system chops, you can concatenate every hour. And the trick is that with this JSON header now, you do not need to take care that the file is longer. So you have your directory, you concatenate all over the day, you can restart your processing, and there will be no sign of invalidity, that something is wrong, some files is missing, blah, blah, blah. This is not of any importance anymore. So these are the strengths, and I hope you find this attractive. That's it.